Since 1961, about 400 humans have ventured into space. For the rest of the 5 billion of us back on Earth, we rely on the pictures and first-hand accounts of the astronauts to share their experience. The pictures have gotten clearer over the years, but the onset of high-definition technology opens a brand new window for the world to witness the wonders of space exploration. Now, for the first time ever, NASA's attempting the first live transmission from space in high definition, and Discovery is here to bring this exclusive event to you. Right now, the 3-man crew on the International Space Station is preparing for this momentous occasion. So pull up a chair and get ready, as we now prepare to link up live with the space station in HD. We're here in Discovery's own state-of-the-art broadcast center, awaiting the first ever live downlink from space in high definition. Hello, I'm Robert Hager. The space station project began in 1998. It's been manned continuously for the last 5 years. Construction is still underway, and it's scheduled to take another 4 years. Currently, on board the space station is an international crew of 3. Thomas Reiter of the European Space Agency, MICHAEL Turin of Russia, and MICHAEL Lopez-ALEGRIA from NASA. Reiter will serve as our space cameraman today, and Lopez-ALEGRIA, or Mike, will be our host. But before we connect live to the astronauts on station, let's get a quick background update on ISS.
Liftoff of Space Shuttle Atlantis.
With the shuttle program back to what NASA calls its normal operational tempo, assembly of the International Space Station is now scheduled to be completed by 2010. Assembly of ISS began in 1998 when the first 2 modules were joined in orbit. And the station's been continuously manned since November of 2000.
We've had crews permanently on board Space Station for about 5 years, and that's a different way of doing business. We're not just going into space temporarily, we're going into space to stay.
A multinational effort, Space Station is the largest collaborative scientific project in history. The construction and operation of a permanently manned orbiting space station is seen by many as a critical leap forward in advancing space exploration. Assembled in orbit, ISS will eventually cover an area as large as a football field. Research in the station's labs has led to scientific breakthroughs that benefit all of humankind.
One interesting thing we're doing on Space Station is we're looking at how drugs and vitamins are absorbed in zero-G and how that differs from the way they're absorbed on the ground.
The Orbiting Science Laboratory also serves as a learning environment for future space travel.
I think in a nutshell, without an ISS, we don't know the right questions to ask for long trips in space and in deep space. Now, while ISS is not deep space, it is a frontier where people can live in space long enough to ask the right questions, to collect the right data. We're doing that now.
Currently living on board Space Station is the 3-person Expedition 14 crew, representing Russia, Germany, and the USA. The crew will conduct many experiments relating to spacecraft systems, Earth observation, and human life science. As with the previous missions, this team's multiple-month stay on station will also serve as a dress rehearsal for upcoming long-duration spaceflight missions.
I think the greatest thing ISS can do is really be that permanent beachhead in space that teaches us how to go beyond. It's the Canary Islands to the Columbus trips and the Magellan trips. It's how do we react to space? What do we need to eat? How should we work? And so a space station is a right step.
Living and working in space, the space station mission continues to help improve life here on Earth, as well as pave the way for journeys farther into the cosmos. Well, there's no doubt that going into space is risky and important work, but it must also be the experience of a lifetime for any brave astronaut who has the chance to go. Being able to share this experience with folks on Earth happens through pictures and personal accounts from the astronauts. The ability to show HD quality pictures from space brings this experience to an even higher level. And having a veteran shuttle astronaut like Pierre Thuot to describe this experience is sort of the icing on the cake. Pierre, welcome.
Thanks, Bob. Great to be here.
Now, tell us about, we're going to see these beautiful, clear pictures. What are you looking forward to in the next half hour here?
Well, I'm sure many of the viewers have seen HD professional football and the clarity and definition there, but heretofore we've only seen standard definition images from space, so you don't get to see the clarity, the resolution of what's going on. And I think just like in a football game, there's a lot of action. There's going to be a lot of action today, and the floating, which is the most fun about being in space. You're going to get to see that in great definition.
So the space station itself up there, 215 miles in space, what's the primary benefit of that for us, do you think?
Well, I think the basic benefit is that it's a research laboratory. We can do things in space that we can't do here on the Earth. You can change pressure and temperature here on the Earth, but you can't change gravity. And so when we do experiments in space and alter gravity, we're able to find things out about materials and medicines and things like that we can't find out here on Earth. So hopefully, 24/7 laboratory, we'll be able to find some new drugs, some new materials and things that we can use here on Earth.
Now, the long-range goal at the moment is to go on, try to go back to the moon, and then jump from there to Mars or even further out, decades from now. But what can we learn that would be valuable for that from the space station itself?
Well, the crews spend about 6 months in space, and if you go to Mars, you're going to take a year, maybe a year and a half. So we need to really understand the human physiology, what happens when people are in zero gravity for that long a time, and also how they're going to be able to walk on Mars when they get there after they've been, say, a year in space. So they're doing lots of experiments on human physiology and trying to understand that, so when we do go to Mars, the astronauts will be able to function.
Pierre, thanks very much. In anticipation of the big event, there's a quick intro to just how amazing pictures from space in high def can be. If you're afraid of heights, hold on. NASA's hoping the brilliant high-definition TV images now being shot on board the International Space Station might make you feel as though you're actually there.
Space is real, and we live in space. So capturing that through high definition brings us closer to being there. And that's an important element of space exploration.
The human eye is a pretty amazing device, and it can see lots of fine detail and fine color structure. HD gets us closer to what you can see with your eye.
One of NASA's main missions has always been to share information about space exploration with the public. From the first manned flights in 1961 to the present day, just over 400 people have been lucky enough to blast into orbit and see for themselves the spectacular panorama of space. The rest of us have had to rely on video technology, and this often made for some fuzzy viewing. Now, with high-definition TV, the days of grainy images transmitted from space are ancient history.
The first HDTV camera that was flown in space was flown on STS-95. It was the John Glenn mission. And I do remember it very vividly. Everybody in the room, it was almost electric for them watching this video, because all of us have been involved with NASA video for literally decades, and it was nothing that we had ever seen before. It was just incredible.
But it's not just about pretty pictures for the viewing public. NASA hopes the sharper images will also help researchers on the ground learn more about our home planet.
If you look at like a sunrise or a sunset, and you can see how thin the atmosphere really is, you know, that little thin blue atmosphere is what keeps us alive here on the Earth. I think you get an appreciation of how fragile our planet really is.
For Earth sciences, it does a couple of things. It allows us to get a moving image, where they do an orbit of the Earth, to get things in better perspective than you might get with still images.
High-definition TV can play an important role in understanding and documenting onboard experiments as well.
It's accurate enough that we can actually use it for measurement purposes, which you can't do with analog video. There's too many inaccuracies in analog video.
High-definition TV has invaded the Earth, the space station, and beyond.
We're now in the HD era here on Earth. Television, movies, and all that. We are really also moving into the HD arena in space for the public. Not only at Mars, not only at Space Station, but also at the Moon. In 2008, we're launching the Lunar Reconnaissance Orbiter, which will carry a powerful set of imaging tools which will produce basically HD imaging of the Moon at scales that we'll be able to see ourselves, the leftover hardware of Apollo. We're in an HD age, and it's going to the planets.
So until the day comes when we can all take a rocket ride into orbit, sit back and enjoy the amazing HD TV views from above.